Hey, good afternoon, everyone. My name is Tom Douglas. I'm with RACO, and thank you for joining us today on our webinar, an introduction on community noise standards. Leading our webinar today is going to be Lee Hager with 3M. He's got over 25 years experience working as a certified occupational hearing conservationist. He's consulted with a number of Fortune 50 companies, served as counsel for accreditation in occupational hearing conservation. He served as president of the National Hearing Conservation Association. He's chaired the Noise Committee and fellow of the American Industrial Hygiene Association. He publishes regularly and presents internationally on noise and different hearing issues, and is currently serving as a hearing conservationist for 3M. So we greatly appreciate Lee's experience and his time. And with that, I will kick it over to Lee. Actually, one bit of housekeeping real quick. We will be recording this webinar, so if you dialed in late or you wanted to share it with somebody, we'll make that available at raco.com at our training page. And if there are any questions during the webinar, there's a little question box that should show up on the right-hand side of your screen. Anything comes in your head, please pop that in there, and we will address all questions most likely at the end of the presentation, but if it's relevant, we'll try to answer it right away. So without further ado, I'll kick it over to Lee, and thanks a lot, Lee.
Well, thank you, Tom. I appreciate the invitation to talk to everybody a little bit about some noise issues that we may not deal with every day, but they're certainly important when we do deal with them. When we're talking about community environmental noise and how things work from there. As Tom indicated, I'm pretty much an ear geek. I've been working in noise and hearing for the last good long time, 25 years plus, and find that increasingly the issues that we're going to be talking about today, the issues of community and environmental noise, are starting to raise their heads. And we'll talk about a little bit the reasons why. Talk about some of the rules and regulations that might govern these sorts of things and exactly what we're going to do about it. This is going to be our fundamental outline for today. The main point to understand is that even though we use decibels, just like we talk about decibels TWA, just like we talk about decibels hearing level, they mean something different in the environmental and community noise measurement process. This is no longer about hearing loss. This will become clear as time goes on. We'll talk a little bit about regulations, talk about which opinions matter, who is the most important judge in the process of determining community noise issues. We'll talk a bit about metrics, instrumentation, talk about property lines, a very, very important process to think about when we're thinking about community noise in particular. We'll talk about annoyance factors, how measurements can go wrong, and we'll point you in the direction of some resources that may be helpful as you're either starting to think about establishing a community noise ordinance or are trying to comply with one that you have already got in place. So typical sources of concern we're going to be dealing with here. The list that you see here is kind of a short one, but covers a large amount of what we deal with in the world of community noise. These kind of divide into two general groups, and the regulations will tend to follow them into two different groups. Vehicle traffic, in a lot of cases, we would consider to be kind of a mobile source. In that situation, the infraction or the violation of the noise ordinance might be kind of a mobile situation. It's not necessarily going to be at a property line. It's going to be something moving down the road. Amplified music, either from neighborhoods, nightclubs, rails, and aircraft. Aircraft in particular is a huge, huge source of concern in the environmental noise situation. The Federal Aviation Administration actually has its own specific sets of rules that deal with noise impact of new construction on airports because it's such an issue. Construction issues like heavy equipment, like compressors and pumps, either stationary or mobile. Firing ranges, increasingly as residential construction starts to encroach on what was originally a rural setting, we find ourselves closer to things like firing ranges that might cause an issue. Racetracks, loud voices, disturbance, these are the kinds of things that we're going to be dealing with in the world of environmental and community noise. And what you will note here is that if I were talking about an occupational noise exposure situation, by now we would have talked about the 85 dB exposure limit. You see in the community stuff we haven't talked about any limits at all yet. That's because the limits are highly variable and highly differential based on the type of land use that's going to be in play. So to reiterate, this is now no longer about hearing loss. It's no longer about 85 decibels. This is about property lines, it's about annoyance, and it's about standards that are miles away from our occupational exposure standards. These are most of the issues that we're going to be dealing with when we're dealing with community noise issues, environmental noise issues. The issue of sleep disturbance is pretty substantial. When people cannot get a full night's sleep because of noise impinging upon them from a neighbor, in particular an industrial neighbor, it winds up being a pretty significant issue and something that some courts have actually quantified to determine that there is a financial value to it. The issue of annoyance, the issue of compatible land use, the issue of stress, fatigue, and interference, in particular with verbal communication, or in my experience, interference with a lot of folks' ability to enjoy their 50-inch widescreen TV and Wheel of Fortune, can be significant. And those are more the things we're dealing with here rather than any kind of hearing loss issue. Hearing loss, typically not going to be an issue at all in a community environmental situation. Now, there are mitigating circumstances when we're dealing with environmental situations. I think the top one of these is probably going to be the most essential. We talk about expectations. In many cases, if you build your house next to a noisy industrial facility, you expect that noise to be a part of your life. On the other hand, if you buy your 10 acres out in the country and an industrial facility builds right up to your property line, you're not expecting that noise to become part of your life. So the question is, what are your expectations? What are the property owner's expectations? And what are the noise generator expectations in this specific situation? There are significant variables for time of day. We'll discuss that when we start to talk about metrics a little bit. Noise is much more tolerable during daylight hours than it is at night because of the sleep disturbance thing we just talked about. There are issues like time of year, atmospheric conditions, as well as issues like windows open, windows closed can have a significant effect on the amount of complaints being received about noise hazards, or excuse me, noise sources in an environmental setting. The duration of the signal, is this something that has gone on forever, or is this something that's intermittent? And I don't want to downplay the last thing on this list, attitudes in general. If the noise is being generated by what the neighborhood perceives of as a good neighbor and a good provider of local jobs, noise issues tend to be far less prevalent than if the noise emitter is considered by the neighborhood to be an intruder or a bad neighbor or somebody who's laid a bunch of people off and therefore is no longer a good economic engine for a neighborhood. So those general attitudes that can be colored by a large variety of different factors, in reality none of which having to do with noise, can have a significant impact on the number and the quantity and the intensity of complaints and issues that we get about environmental noise situations. So this is kind of where things start. Typically, we'll start to see complaints be generated when the offending noise is about 5 decibels louder than the ambient. That is, if we take a noise measurement in a location with the noise source off, take the same measurement with the noise source on, if there's more than a 5 decibel or so difference, that's when complaints start to kick in pretty seriously. Now those complaints will tend to ramp up and become vigorous, become significantly more vigorous when the noise source is about 20 decibels louder than the ambient. So these are just some general guidelines when we're talking about siting a new facility or siting a new location. These are things we need to keep in mind. What is going to be our contribution to the ambient noise at the property line? if we're going to be 20 decibels louder than it is before we put our plant in, we will have noise issues. We absolutely will have noise issues in that kind of situation. So this gives you a general indication of when you can start to look for when noise can become a significant issue. This is a discussion of the metrics that are most commonly used in the environmental noise situation. The most key one of these is the level day-night, or the LDN. When we talk about noise being more or less acceptable based on the time of day, daytime noise is typically more acceptable than nighttime noise. That is actually reflected in this calculation. The assumption is that when we generate an LDN, or a level day-night, that we have a 24-hour sample, and that we weight the sample during the period from 10 p.m. to 7 a.m. with additional 10 decibels. So if we measure 50 decibels at 11 o'clock at night, we're going to factor that into our overall measurement as 60 decibels, 10 decibel penalty, with the assumption that people have expectations of more quiet at night and that higher sound levels are going to be sleep disturbances. So the math you see down here, the development of the LDN, reflects how the 10 decibel penalty is factored in between 10 p.m. and 7 a.m. The community noise equivalent level, or the CNEL, is the same as the LDN, except with additional penalties between 7 and 10 p.m. That measure is unique to California, and basically it follows the same thought process, the same pattern, except that we have the 10 decibel penalty from 10 p.m. to 7 a.m., and we'll have a 5 decibel penalty applied from 7 p.m. to 10 p.m. with the thought that people are going to want to enjoy the outside space. What we see here from the 1974 Environmental Protection Agency community noise levels, this actually comes out of the Seminole Levels document, one of the most powerful noise documents ever generated by the government. These are generally what we would consider to be compatible land use guidelines. These would be the levels that we would expect to encounter in these various types of environments. A rural environment, 35 to 50 dBA LDN, again with a 10 decibel penalty at night. A quiet suburb at about 50 decibels. A normal suburb at about 55 decibels. You can see as population density increases and as traffic increases, those sound levels are going to increase as well. So this gives you an indication of what we would expect to find in these various types of residential environments related to the noise levels. Now, the other thing that we can kind of consider here is that if we're in a quiet suburb and we have a sound level that's generating about 70 decibels, would we anticipate some noise complaints? Well, yes, vigorous noise complaints, as you recall. When we get to levels that are 20 decibels above these levels, then we're running into significant issues. And even levels on a 24-hour LDN basis of about 5 decibels above these levels can generate some complaints. That's where complaints can really start to kick in. So these will provide you some general guidelines as to what we're looking for in various places. The American National Standards Institute has also fairly recently published a series of standards that discuss compatible land use, a little bit more updated than these 1974 EPA standards, and a little bit more detailed in terms of the type of land use anticipated. So those could be a good resource for anybody who's looking to develop a community noise standard or get a sense as to where they fall in with their particular compatible land use processes. Those are ANSI, I believe they're ANSI S129 A through H. So you can kind of take a look and see if you can find those. They're available from the Acoustical Society of America. Now, who is the expert here anyway? Who is determining what these appropriate levels are going to be? Noise regulations, community noise regulations, kind of break down into 3 primary components. The federal level, actually not much of an influence. What we saw in the EPA guidelines were exactly that. They were guidelines, with enforcement being left to the state or the city municipality of their own noise ordinances. What this really means is that there are a plethora of different noise ordinances that are currently in play in various parts of the country. The criteria in those standards and the way those standards are enforced and the permissible noise levels, all of those things are going to be highly variable based on the state, based on the city and municipality. To give a general sense of where we would expect to start to find annoyance, take a look at the little equation there on the bottom. If you run that equation, it will give you a very gross estimation of where annoyance or where noise complaints are going to start to kick in. You see that the key variable here, of course, is going to be the population density, number of people per square kilometer. But if we solve this for LDN, basically plug in the number of people per kilometer squared, we could get an initial handle on what the annoyance factor is going to be and get a sense as to whether or not, at what level, those noise sources, or excuse me, those noise complaints are going to start to come in and whether they're going to start to be significant. So we talk about there being a huge variety of different types of noise ordinances. These are typically common elements that we'll find amongst most of them. Typically, there'll be an issuing authority. This is going to maybe the county, maybe the city, maybe the state, maybe any of a number of different enforcement agencies. There'll be a statement of purpose, what we're trying to accomplish with this noise ordinance, series of definitions, the metrics and the methods for measurement, which will vary pretty significantly between states and cities and municipalities, and special situations and exemptions. Most commonly what we see in the special situations and exemptions issues are allowances for temporary exceedances. For example, the city of Milwaukee has a fairly substantial noise ordinance, but you can absolutely rest assured that when it comes time for the street fairs in the summer, well, we're certainly going to exempt some of those bans from those noise standards on a special situation basis. Sometimes with permits, special situations can be accommodated. So these are the common components that are going to run across all the various regulations that we see that are talking about community and environmental noise. Now, this is kind of an interesting question. Whose opinions matter? Who is the judge in this process? Who determines whether or not there's a problem and what the problem is going to be? Well, beauty truly is in the ear of the beholder here. The perspectives of the annoyed person, the perspectives of the enforcer, and the perspective of the accused are going to be significantly different. That's why it's such an important thing to have published standards for community noise on a local basis, so everybody has a common ground where to start from to determine whether or not there actually is being a violation and what the outcome of that violation should be. But each one of these different parties has a different perspective on the process. The annoyed person simply wants to be able to enjoy their property, including their backyard and their barbecue grill and their 50-inch television. The enforcer just wants to make sure that the standard is being met. The accused basically wants to continue to make widgets at an ever-increasing rate, and regardless of the noise that may be emitted. So you can see those different perspectives are going to lead people to draw different conclusions and take different actions on community noise kinds of issues. These are the most common metrics that we use when we're talking about community noise measurement. Typically, an integrating sound level meter or perhaps an octave band or third octave band sound level meter is going to be appropriate for doing this type of measurement. Many community noise ordinances actually specify permissible noise level by frequency. They do that because most commonly low frequency noise is going to be far more pervasive and far more annoying than high-frequency noises are going to be. So that's the reason that we're going to need to think about having an octave band or a third octave band sound level meter. But the meters need to be equipped with a sufficient measurement range to be able to capture what we're looking at here. Now keep in mind that when we're dealing with OSHA in an occupational noise situation, we don't even start measuring noise on the dosimeter until we get to 80 decibels, right? We use an 80 decibel threshold. Well, that is 180 degrees different from what we're talking about with this community situation. For community noise levels, we need to be able to measure and document extremely low sound levels as low as 30 to 35 decibels, and to be high enough to capture whatever excursions may occur that would create the noise issue to start with, and create the noise problem or the noise complaint to start with. So a broad dynamic range is going to be an important thing. We need to be able to measure quiet enough and loud enough simultaneously. We need to be able to measure either in A-weighted, C-weighted, or Z-weighted linear measurements. Typically, if we're taking a broadband measurement, it's going to be either linear or C-weighted in an environmental situation, since A-weighting is essentially designed to mimic the hearing loss in the human ear with a given noise exposure. So if we're not concerned about hearing loss, we'd more than likely be looking at linear or C-weighted noise noise measurements. Fast or slow response will typically be specified in the standard. Peak and impulse measurements may be required in some situations, in particular when we're talking about things like firing ranges. In those situations, we're going to need to capture an unweighted peak and a relatively rapid impulse sound with the equipment that we're doing the measurement with. We'll want to be able to measure a simple average or an LEQ, and we'll also want to be able to take that measurement and apply the 10 dB penalty LDN CNEL measurement to that. Most of this is going to be internal for most integrating sound level meters, but it's certainly the parameters that we're going to need to check. The L10, L50, L90 are indicators of what level is exceeded 10% of the time, what level is exceeded 50% of the time, what level is exceeded 90% of the time. So in some community noise standards, we may have a metric of 50 decibels, but 55 decibels L10. That would permit us to exceed that 55 decibel limit, but for a short period of time. And some of these L10, L50, L90 measurements will actually be specified in the noise standards that we're dealing with. We talked about octave bands, we talked about real-time analysis, both very important tools when we're starting to march down the road of the community noise issues. A little comparison of A and C weighting curves. These are the same curves we use in the occupational world, but they also have some applicability in the world of community noise as well. The C-weighted curve is much more flat and actually would be much more commonly used in the world of community environmental noise. We talk about response time of the meter. These are the ANSI-specified response times for fast response, slow response, impulse response, and peak response. So this is essentially the responsibility of the preamp of the sound level meter to be able to accomplish this, but it can give you an indication of why you see a difference between a fast and slow measurement when you have a highly impulsive kind of noise. It'll give you an indication of where some of that may come from. We talked about response time. What you see here, the curved line there, the squiggly line, is actually an acoustic trace of gunfire. Okay. The horizontal line at the top says peak, the highest unweighted excursion during the entire sampling period. So unweighted, fast response, how high did that sound get during that measurement period? That's an indication of the peak. The L max is typically the highest slow response reading. You see the difference between fast and slow in some situations. It'll be reflected right there. And then the line that starts up and turns down at about 20% across the page, that is an indication of the L average, or the root mean square, essentially the average sound level over a period of time. The message here is that a noise event has a sound pressure level factor without a doubt, but it has also got a significant time factor. Without considering the time factor that's involved with these events, we really can do ourselves a disservice by not doing an appropriate assessment as to the impact of a given noise in a given community environment. The LEQ, of course, is going to be one of our standard requirements. What you see is basically we'll use a 3 decibel exchange rate for the most part. The equation that's at the second bullet there, it gives you an indication of how we derive that LEQ, that equivalent sound level, time sound pressure level, and the reference sound pressure level. So that's essentially where we're at and how we develop that LEQ. The good news is that the average values, the LEQ values, are most typically generated by the instrument itself. Typically, a sound level meter will be able to integrate that and provide you that average. But it may be useful for us to understand how that average is derived. That can answer some questions for us as well. We talk about the exceedance levels. I'm not sure what the band's exceedance level is. I think that's probably about an L1 to me, but I'm not exactly sure. Just to give an indication of the levels that are exceeded a given period of time. We talk about octave band filters. It's important for us to realize when we're doing octave band sound level measurements that we'll put a value on an octave band. We'll call it, for example, the 63 hertz octave band. But in reality, due to the sloping shoulders on the filter, that will actually capture energy between about 44.5 and about 90 decibels. Now, the amount of energy it captures at those extremes is going to be extremely low. But there will give you an indication that just because we say 63 hertz doesn't mean we're measuring a 63 hertz pure tone. We're actually capturing energy around 63 hertz with an emphasis in the center of 63 hertz. This is an example of what one of those octave band analyses may look like. So we see time across the bottom. We see LEQ that increases from 12.5 hertz on the left side of the screen all the way up to about 20 kilohertz. So this is a fairly reasonable octave band analysis. Pretty typical of what we'll find in most industry, a lot of energy in the 1600 to 2000 hertz range, not so much energy way, way down, and not so much energy way, way up. So this is what an octave band analysis will actually look like once you get it out of the meter. So we're going to want to use a sound level meter or an integrating sound level meter to do this work. Some noise dosimeters can function okay as in doing community noise. The hazard or the caution that I would hazard you is that we need to be careful when we're using dosimeters to do this measurement if the dosimeter has a sufficient dynamic range to capture the levels of interest. If we're trying to hit a 40 decibel property line measurement and our dosimeter doesn't start to integrate any kind of sound until 45 decibels, well, it's not going to be the instrument of choice. The data logging devices will be used, frequency analyzers, real-time analyzers will be used. What you see in the photo in kind of the lower left here is actually a setup that has been developed for a noise enforcement officer to be able to issue a ticket based on a sound level meter reading on the spot. The plan is we measure the noise with the meter hooks up to a printer. When we press go, it sends out those sound levels to the printer and generates a summons. It'll generate a ticket for excessive noise. So something you can do on the spot. It's kind of an interesting way to try to enforce noise ordinances across the country. It's also important for us to think about what we're doing with the type of instrument. By type, I mean class of instrument. Most commonly in industrial settings, we're using type 2 sound level meters. You see the right column here, a type 2 sound level meter, we're typically going to consider to be plus or minus about 2 decibels. But you see there's actually some variability in that based on the frequency in question. A type 2 sound level meter may be plus or minus as much as 5 decibels when we get up to 8,000 hertz. Might be even more than that at 10,000 hertz. Type 1 instrument is absolutely going to be more precise, going to be substantially more expensive. But the critical thing is to look at the ordinance that we're trying to comply with. In most cases, those ordinances will specify equipment. They will specify the type of sound level meter, type or class of sound level meter that should be used to comply with their requirements. Now, when we're dealing with community noise issues, the most important concept to grasp is that of property line. Property line is where ownership of property converts from one entity to another. What you see in the picture here is that we've got the factory, we got some open space that the factory owns, and the property line is this little vertical line right here next to the beautiful lake house, right? And what we're going to be concerned with when it comes to community noise ordinances is the effect that the factory is actually having at the property line. That's where we'll do the measurement to determine whether or not we're in compliance, whether or not we're causing an issue. So this whole issue of property line is very important. I'm not going to take a measurement here. I'm not going to take a measurement closer to the plant. I'm going to be almost exclusively concerned with what effect is my factory having on the neighbor's use of their property. What is the sound level at the property line? That is going to be the most critical thing to think about. Now, property line can mean a couple of different things. Property line can certainly mean at the ground, but it can also mean in a high-rise. Property line is property line. It starts at the ground, but it goes up infinitely. We actually ostensibly own the air above us, at least as far up as we can breathe it. So this issue of property line is going to have an effect even in a situation where we're dealing with an apartment building with multiple floors. The guy on the 7th floor may be having an issue, but we'll be trying to determine what that property line sound level measurement is. That's the measurement that's going to be of interest to you. And we're talking about right there. That's what we got for property line on this particular situation. Maybe 10 stories high, but that's still the property line. Now, not all noise is created equal. Certain types of noise can be significantly more irritating, annoying, and be the source of more complaints than other types of noise. The primary thing that we see, in particular when we're dealing with industrial complaints and community noise issues, is low frequency. Low frequency tends to travel. Low frequency tends to skip in some situations based on atmospheric conditions. Low frequency is very, very difficult to control. So that is one of the primary things that we deal with. It's the hum at the property line. It's the boom at the property line. Those are the signals that are causing us the greatest amount of complaints in the community noise situation. The human voice, interestingly enough, is considered to be a very, very annoying factor. A given sound pressure level of music over a PA system as opposed to the same sound pressure level of human voice, of people talking, can be significantly different. The human voice, because it demands our attention, will tend to annoy us more than other types of sounds. Pure tones are another situation. They're highly annoying. If we can identify a pitch or identify a given pure tone with the annoying noise source, the presence of pure tones is significantly more annoying than broadband kind of sounds. So in some cases, that's why a squeaky belt or a squeaky fan can cause significantly more noise, community noise issues than other types of noise, and air handling units, for example, because those pure tones are extremely distracting. And of course, sudden dramatic changes from the ambient. I think we're probably all resistant to change at one level or another, but one of the key annoyance factors when we're dealing with community noise is dramatic, sudden changes from ambient. Even if the ambient is slightly high, a significant change can make a significant difference. Consistency is easier to deal with than intermittency in this kind of environment. We define ambient, of course, as a background noise level without the offending noise source. We'll most commonly use an L90 to identify that, which is to say this is a level that's exceeded 90% of the time. how do we get an assessment? How do we determine what the ambient noise level is and therefore determine the contribution of the offending noise source? Well, the best way to accomplish this is to select the property line's sound level location and then stop the source. If we know that the source is a fan, can we shut that fan off to take an ambient measure, get the measure without the offending noise in place? If that's not possible, in some cases we can select a like location, the same distance, the same topography as we were initially concerned with, but without the offending noise source in place. So instead of measuring on the north side of the plant where the fan is squealing, well, let's take the similar distance to the south side of the plant. Maybe that would give us a good indication of what the ambient noise level would be without the offending noise being involved, rolled in. If a source is within about 3 dB of what's going on around it, the source is really not having much of an effect. Differences of 3 dB are not a huge thing. Between 4 and 10 dB, there is a mixed effect. If you recall, we talked about the noise complaints starting to roll in when there's a 5 decibel difference. Well, that falls right here and is in between 4 and 10 dB. But if the source is greater than 10 dB above the ambient, then it turns out the ambient is not doing much. The ambient is really not contributing, and the source is going to be the primary contributor. So looking at the difference between ambient noise and the noise with the source on can give us a good sense as to where we need to go, whether this is something that actually is going to require control or not, or whether there may be other issues at play. Now, even if a source is within 3 dB of the surroundings, though, if some of the things we just talked about, things like pure tones or things like low frequency or dominant, they could still be the source of some significant complaints, significant issues. So this gives an indication of what can happen with various variables, if you will, when we're talking about community noise. The expectations piece is large. Do we expect the plant to make noise? Do we expect there to be noise here? If we don't expect noise, it can make a significant difference in the amount of complaints that are being provided. We expect things to be quieter in the summer than we do in the winter. And the tonal issues that are involved with what's going on can be significant. So these are all things to kind of keep in mind as we're starting to do these measurements. All these variables could come into play. So how can the measurements go wrong? Well, seasonal factors. Absolutely, seasonal factors are going to be huge for a couple of reasons. Seasonal factors can have a significant effect on source production. If factory windows and doors are open or closed, if there are other issues that are, if receiving houses, windows are open or closed, all those things can have a significant effect on the amount of complaints that we get. So we need to make certain that when we're measuring, and we're measuring ambient and we're measuring the source, that we're measuring it under the seasonal conditions under which we want to capture. We just need to make sure that that's documented and captured, that this is the time of year we did that. Weather can be a significant issue. In particular with low frequency stuff, rain can make a difference, temperature inversions can make a difference, excess humidity can make a difference. There are a number of things, meteorological things, that can make a difference. In particular, if we're talking about a long distance from the noise source to the property line. Those things can kick in pretty significantly. Selection of measurement location is absolutely huge. We need to make sure that we're measuring at the right spot to get the right conditions, to get exactly what it is that we need to get. And source operating parameters. There have been far too many community noise studies I've been involved with that have been probably unconsciously sabotaged by the plant. Say, well, geez, if you're going to go out there and measure the noise from this fan, let me shut the fan down. Well, the fact of the matter is we need to make sure that the source is operating in its standard conditions before we start to do the measurement. So with seasonal factors, plant conditions, insect and wildlife activities, wind patterns, ground conditions, the insect and wildlife activities can actually be significant when we're starting to talk about ambient noise levels in the 35 decibel range, and cicadas and tree frogs. They can actually exceed that ambient pretty substantially just through their natural noises. It's part of the ambient, but it's the point where it exceeds the limits that we're looking at. Here we can see what temperature inversion can do for us. What's going to happen to noise flow depends on where the inversion lies, and the strength and nature of the inversion can make a significant difference in how sound flows. The meteorological conditions we discussed, absolutely going to be a key part of the process. A couple of ways you can keep a handle on what's going on with the environmental conditions, with the weather conditions. Certainly weather radio on the phone, field measurements for wind speed, things like that can certainly be used. A couple of websites where you can find current weather conditions, all of which are important to document as we're walking through the process. And precipitation, of course, is going to be significant. Whether it's actually raining or whether there's significant snowfall, condensation. Condensation could be a significant issue on the microphone of a sound level meter in some cases. The presence of noisy natural events like thunder, those things can all add up to make a difference in the community noise measurement that's being taken. So conditions need to be carefully documented. And we discussed a little bit about measurement location. Source operating conditions going to be absolutely critical, making certain that the noise source is being operated in its standard condition in terms of what we're making, the rate at which we're making it, all those kinds of things. All of these things need to be carefully considered and documented as we start to take our community noise measurements that will be compared to the ambient. Site selection is going to be pretty important. In most cases, we're going to be dealing with a property line or a noise recipient location. I've actually done noise measurements inside living rooms and inside various other places in people's houses where they perceive the noise to be worse. Property line is probably going to be the most critical one of those, but it's important to keep in mind that the site selection is going to be controlled by what we want to use the measurement for. What are we trying to do with this? If it's a compliance issue, then we really need to specify whether we're going to be at the property line or some other specified location. Good guidelines as to how we're going to use the instrument. Between 4 or 5 feet off the ground, the ordinance standard may require a different height, and there are different ordinances all over the place. Keep in mind we want to be able to see the source as much as possible to maintain a clear line of sight. That clear line of sight will ensure that we're not getting any significant reflections. When we start to talk about property line on the 10th floor, this can become kind of a problematic issue, without a doubt. But these are the challenges that we deal with when we're working in this business. You need to know the type of microphone that you're using. The pictures on the bottom here are giving an orientation guide as to the type of microphone and how the sound should impinge on the microphone. Free field microphone should be pointed directly at the source. Random incidence at about 70 degrees, and a pressure microphone across the surface of the microphone. Understanding which microphone you're using, understanding which microphone is installed on your meter can make a significant difference, can significantly improve the quality and integrity of your measurements. We need to be able to calibrate the system and document that calibration, absolutely. Field check before and after each measurement, and factor laboratory calibration on a regular basis. An example worksheet here that you can use to sketch out the measurement locations, give an indication of the measurement step, and the various parameters that we're going to be looking at: average, peak, minimum and maximum sound pressure level, A-weighted and C-weighted, and octave bands. So this might be a good guideline to give us a sense as to the type of information that we need. Room for 4 different measurements so we can identify what's going on. The one resource I want to bring primarily to your attention here is the one at the bottom. The Noise Pollution Clearinghouse at nonoise.org has undertaken kind of a project to assemble and compile as many city, state, local community noise ordinances as they possibly could. They have a large repository of different community noise standards and guidelines. If you're thinking about putting together a community noise ordinance, or if you think you might need to be in compliance in some place where you haven't been before, this is a real good place to start to get an indication as to Well, okay, what are going to be the rules here as we build our new plant outside Fargo, North Dakota? This can give us an indication of what our design parameters might be and how we need to lay out the plant. So check out nonoise.org, absolutely a great resource, as well as the Cyril Harris book and the AIHA Noise Manual. Both have very strong chapters on community noise ordinance. So I think we may have time for a question or two.
Yeah, thanks a lot, Lee.
Well, thank
we
you.
had somebody type it. Yeah, somebody was asking about sound level meters, what scale is best used for decibel measurement. And they were asking A, B, or C. And I don't know, I think they might be meaning the A or C weighting, I believe.
Right. Yeah, it really depends on the ordinance that you're dealing with. In most cases, I would prefer to see property line measurements done linear with no weighting. My second choice would be C weighting. C weighting will give a little bit more emphasis and help you to identify those low frequency sounds a little bit better than what we could with A weighting. So those would be my choices. But again, I caution you to look at the standards and regulations that you're going to be dealing with. Those are the places where you're going to find the best guidance.
Wait and see if any more questions come through here. Looks like somebody had their hand raised here. We're looking for a question to come through. Just a moment.
We did have kind of an earlier question that came to my attention here, Tom. It's something else that I would like to maybe mention. This doesn't deal directly with community noise ordinances, but it deals with kind of community relations as far as it deals with noise. My experience has been in a lot of situations that people will lodge noise complaints based on what they see. Okay? I know it doesn't make any sense, but people will say, those trucks going in and out of that gravel pit are just too loud. When in reality, it's simply the traffic that's causing the annoyance, or maybe the dust that's causing the annoyance, not necessarily the noise from the trucks. So the one piece of guidance that I would provide is, where possible, keep operations behind a green screen. Keep operations, plant some fast-growing shrubbery along the driveway or something that will block the visual into the operation. And by controlling that visual in a lot of situations, you actually can ameliorate some noise issues.
Great tip. Yeah, not really seen anything else come through, so I think we'll sign off at this point. So all those that were in attendance, we really appreciate it. Again, we'll make this recording available and the slide deck at rayco.com on our training page. Any other questions, please feel free to email me at tom@rayco.com or lee at lhager@mmm.com, and we'll be happy to help you out. And if there's anything else, we'll sign off. Thanks again, Lee. We really appreciate it.
Absolutely, my pleasure, Tom.